Welcome back. Here's another little introductory problem with a voltage source and some resistors. And we're just going to use Ohm's law, KVL and KCL. And I guess what's going to happen here is that if you choose Ohm's law, KVL, and KCL in the right way, you can get the solution to come out a little bit easier. But really later on in the course, we're going to have some better methodology to get this stuff done. But this is a good problem with some good introductory concepts. So let's do it. Sorry about that resistor, a little bit ugly. And there we go. So we've got these resistors. So there's a 20 ohm guy here. There's a 4 ohm guy here. There's a 22.5 ohm. They picked these to make the answers come out nice. 15 ohm to make the numbers come out right. And a 240 volt source. We've got a current I sub S coming out of the source. I sub S, that's an S. And we've got a node here, and a node here, and a node here. Let's label these. This is A, this will be B, and this will be C. And we've got a bunch of currents in these branches here. Well, okay, so this is given, this circuit, but what they're asking you to find, all right, always list your givens and your finds and what you're doing. They're asking you to do a power balance. So, therefore we need all the I's because we have all the R's. Oh, there's one right here too. Yeah, this is a 5 ohm. We have all these R's. So if we had the I's through there, we could use I squared R, right? So let's label all the I's. So let's call this I1. Let's call this I2. And I'm not really guessing the current direction. I kind of know what it is, but a lot of times you're guessing, but you try and guess right. But look what's happening here. You've got this I source coming up. It's going to come to this point. It's going to split. I mean, imagine these were pipes, and that's what would happen, right? The water would come that way and that way. And you'll get more comfortable with that kind of thing as time goes on. Okay, then these two guys, the current through here is trying to get back to the negative terminal. So this current's going to go that way. And so let's call that I4. And this current's going to go that way because they're trying to get home. Right? So this source is coming in and splitting. And then on these guys here, they're collecting at this node down here and trying to get home. The only one that's a little bit more tricky is this one. Which way is it going? Is it going this way? Is it going that way? Well, if you look at these two resistor values, this one's bigger. So this is a more difficult path to get home, right? So the current's going to go towards this easier way. So this current here is going to go that way. Let's call it I3. So these are correct guesses for the current, but a lot of times you don't know and you're still just guessing. But guess something, and if your answer quantities at the end come out negative, you guessed backwards. Is all that means. Okay, so try and guess correct, and then hopefully you'll get positive numbers. But if you get negative numbers, it just means that you guessed backwards. And you could rework the problem with different guesses, or just adjust those negative numbers. All right. Now the methodology that we're going to use here is we're going to carefully pick Ohm's law, KVL, and KCL to get an answer, to yield an answer, to yield a quick result, a quick number, So we're going to do, so it turns out, if you look, I2 right here, oh, there's some more givens. This is given, it's 90 volts. The polarity is going to be this way, at the current coming into the positive. Right. So we're given the voltage and the current here. I'm sorry, we're given the voltage and the resistance. So Ohm's law will give us the I2 current directly. So Ohm's law at the 22.5 resistor is going to give us I2. So Ohm's law is V equals IR. So I2 is going to be 90 over 22.5, right? It's going to be the voltage over the resistance. So this is going to be 4 amps. So that's an answer that we're going to need later. So I'm going to mark it with this doubly thing there. Okay, what should we do? What should we do next? If you look, we've solved for this voltage. We have this voltage. If we go around the outside loop, the only voltage that we won't have is this one. So we'll be able to get this voltage. And then once we have this voltage, we'll be able to solve for that current, similarly like we did up here. Okay, so go around the outside here and call that loop 1. And there's 4 loops in this thing. There's the outside loop, there's a loop around in here, there's a loop around in here, there's a loop around in here. There's 4 loops. But if you choose this one around here, the only unknown is this voltage here. So let's do that. So KVL 1, so we're coming into the positive 90 sign, so it's going to be 90. Okay, let's put polarities on all of these resistors. So the current coming down this way, it's going to be plus minus. Current coming down this way, it's going to be plus minus. Current coming down this way, it's going to be plus minus. Current going across this way is going to be plus minus. All right. So plus 90, plus 15, minus 240. Those sum to oops. Plus 90. I need a V, and this is a variable here. I don't know what this is yet. Plus, I could call it something. I could call it V across the 15 ohm, but it's I could use Ohm's law there too. So it's 15I5. This is IR, which is a V. This is a V. This is the V across. So there's positive 90 I'm dropping here, and then I'm dropping 15I5 volts. I'm using Ohm's law here. This is a voltage. 90 is a voltage. 15I5 is a voltage by Ohm's law. Okay, so just to reduce the number of variables. Otherwise, I would have had to name this V something and have another variable, and it's more stuff. So, Kirchhoff's voltage laws, we're summing voltages. So I got this 90 volts, and then I got a 15I5 by Ohm's law volts that I'm summing, and then I'm coming into the negative terminal on this 240 volts, so it's minus 240 equals 0. So I5 falls out of that. So I5 is the only unknown in this, so I5 is going to be solving for I5, move the 240 to the other side, move the 90 to the other side, and divide out by 15. This guy is going to be 10 amps. Okay, so by carefully choosing this first one, you get this I2, and then by carefully choosing this second thing to do, you get the 10. Okay, what should we do next? If you look here, we've solved for I2, 4 amps, and we solved for I5, 5 amps. So this must be 3 amps. I3 must be 3 amps. So let's use KCL at node B. Basically, I3 must be I5 minus I2. I3 is I5 minus I2. If you don't like that, let's do ins. Let's just do sum of the currents equals 0. So and we'll do in is positive and out is negative. Let's do that. Just if this is if arriving at this right away is a little bit tricky, do it slower. So in, we've got a negative I3. Let's do the out first so that it looks pretty. So we've got I5, and then it's coming out. That'd be negative because it's coming out. And then I've got two guys coming in. I've got I3 and I2. So I3 plus I2 minus I5 equals 0. You can do that. And then I just solved it for I3. Okay, either way you want to write these. Just this is the more, this way over here is the more like mechanical way to do that, but they should all agree algebraically. Okay, different ways to write these things. So we have I3 now, right? Because I3, we have I5 that was 10, and we have I2 that was 4. So this is 6 amps. Okay, now what do you want to do? If you look at if you look at this loop right here, let's call that loop 2. We've got the 90 volts. We've got I3 and 5. So by Ohm's law, we've got the voltage here. We could get the voltage with the 4 ohms and I1 here, and the only unknown would be I1. So that one will work. So do KVL at loop 2. So let's write our KVL. We'll go around this way. We're coming into 90, so it's going to be positive 90, and then we're coming into negative. This negative voltage drop here is going to be, by Ohm's law, it's going to be 5I3. Then we're coming into the negative terminal of this voltage, so it's going to be negative because we're coming into the negative terminal, and by Ohm's law the voltage is going to be 4I1. Those sum to 0. I3 is known, we just solve for that. So I1 is doing the algebra too much all at once. Move this to the other side, you're going to get 90 minus 5 times 6 over 4. I3 is 6. So I'm just solving this algebraically and putting in the value of I3. If that confuses you, then write out the intermediate algebra steps. No problem doing that. The answer is I1 is going to be 15 amps. Okay, double line just to indicate that's a useful quantity. Okay, what do you want to do next? Well, we've got I1 here. We just solve for that. We have I3. So we've got 15 amps coming in here, and then 6 amps leaving this way. So there must be 9 amps going down this way. Okay, so more officially we'll write KCL at A, and I'll do in is positive and out is negative. So I've got I it's coming out. I've got so who's positive? In is positive. So I1, okay, and then I3 and I4 coming out. So minus I3 minus I4, those sum to 0. In other words, solving for I3, which is what we're trying to get here? I4. So I4 is I1 minus I3. It's going to be I1 is 15, right? Over here, 15 minus I3 is 6. Nice quantities to keep track of. There's too many freaking quantities. It's 9 amps, right? Then what's the next thing we can get? We can get this IS right here, right? Because we have I2. We solve for I2 somewhere in here, and we solve for I1. Okay, so we'll do KCL at node C, and just writing all of this stuff out. In is positive, out is negative. So I've got I sub S coming into node C, right? I've got this guy coming in, and then out I've got I1 and I2. So minus this is an S, minus I1 minus I2, those sum to 0. So I sub S is I1 plus I2, and I1 is I1 is 15, so 15 minus 4 is, where's 9? Plus 19. Okay, we've got all the currents. We've got IS, we've got I1. To make a table. I'm going to make a table because I've got too much stuff floating around here. So what we got so far, IS is 19, I1, I2, I3, I4, 1, I2, I3, I4, I5, I5. I got all of these dudes somewhere. So I1, I2 is 4, there it is. So I5 is 10 amps, I4 is 9 amps, I1 is 15 amps, and I3, where are you? Six amps. Okay, we can do a power balance now. So power at the source, just use IV. At the source, you're always going to have to use IV. You need both of these things. It's not a resistor. So this is going to be 240 volts. That's V. And IS is 19. What is that? That's 4,560 watts. And the current direction relative to the voltage potential is this orientation, which is a source. Okay, the resistors should all be loads, and we can use I squared R. So power at the 4 ohm, the 4 ohm resistor is going to be, it's going to be I1 squared times 4. Power at the 22.5 ohm resistor is going to be I2 times 22.5. Power at the 5 ohm resistor is going to be I3 squared times 5. Power at the 20 ohm resistor is going to be I4 squared times 20. Power at the 15 ohm resistor is going to be I5 squared times 15. Did I say 50? So this is, we'll work all this junk out, right? And anyway, if you do all of these things, plug in these values, you're going to get 4560. The sum of these guys, which matches this, and it's all good. Okay. But show your work, do all the details on this thing. All right? Okay.